Section 6 is on the chain rule. And we're only going to look at one application of the chain rule, which is when we want to differentiate like a bracket to a power. Okay, I actually did mention briefly the chain rule in the earlier videos, when we were looking at the shortcuts. So like if it was sine of a function, or if it was an exponential to a power of a function. So with that in mind, because I've already mentioned it, I'm just going to briefly show you like why this technique works. Okay, so say if we had a function, any function at all, to the power of n, so any power. Okay, we've clearly got a function inside another function, which is our power. So remember how the chain rule works? We said, well, if we want to find dy by dx, we could say, well, that would be the same as dy by du multiplied by du by dx. And we just, essentially we did the substitution, didn't we? So I said, well, all right, instead of this complicated thing that I can't differentiate, if I simplify it into, let's just say u equals f of x, we'll just replace that function with the letter u. Then y would equal, well, instead of f of x to the power of n, it'd be u to the power of n, wouldn't it? So we've got two simpler things that we can actually differentiate. Du by dx. Well, if I'm differentiating this side with respect to x, let's differentiate this side with respect to x. I'll just call that f dash of x. Y, now be careful again, this is a function of u. Okay, so I'm not going to be finding dy by dx. I'm going to be finding dy by du. Okay, so if I differentiate u with respect to u, it's just the same as x to a power. You've been doing this since last year. If you want to differentiate x to a power, you times by the power and you take one off the power. So this would look like n u to the n minus 1, just by realizing this is a polynomial to a power, so we'll times by the power, take one off the power. Okay, so applying our chain rule, which tells me dy by dx depends on it. Dy by dx would equal dy by du multiplied by du by dx. That I could say, well, right then, dy by dx would be dy by du, which is n u to the n minus 1, times by du by dx, which is f dash of x. But if you remember, the key thing with this, the original function that we're being asked is a function of x. Now we've got a derivative, but we've also got this u in the way. And like we just introduced u to enable us to differentiate this. Like the original function was saying, look, there's a function of x, I want to differentiate it with respect to x. So our final answer needs to be an answer with x's in, not an answer with u's in. Okay, so we've got n, I'm going to just rearrange this, so I've got n times by f dash of x, because when we multiply things, we can multiply them in any order, like 2 times by 3 is the same as 3 times by 2, so I'm just reordering this. And then I've got u to the power of n minus 1. Okay, now what do we know about u? Well, u is just our original function, which was inside this power, wasn't it? So it would be f of x to the power of n minus 1. I appreciate that this is a little bit abstract, okay, but that's like a rule that we can use to differentiate any bracket to a power. And I can sort of simplify it like this. We multiply by the power. We also multiply by the derivative as well. And we subtract 1 from the power. Okay, don't worry if you didn't follow all of that, guys. All right, we're going to do a couple of examples, and as long as we can apply this technique, which is in your booklet, multiply by the power, subtract 1 from the power, multiply also by the derivative, we should be quickly able to differentiate these functions that we're looking at. Okay, so example 8 from the booklet says differentiate 1 minus 3x to the power of 10. And obviously, first of all, we need to identify that, well, this is a bracket to a power. And if you really wanted to, because the power is 10, you could do a full binomial expansion on this. You'd end up with 11 terms, and it would take you ages. And clearly, we don't want to be doing that. There's a much quicker way of us differentiating this. Okay, I'll do it using the shortcut in a second, but I'm just going to show you what the chain rule looks like for this, because I appreciate that it was a bit abstract before with all the f of x notation. So if you look at what we've got, right, if we say y is equal to 1 minus 3x to the power of 10, we've got a function inside another function, and that's where this substitution is really useful. Okay, so what I'm going to say, I'll say, let's let u equal 1 minus 3x. And that simplifies to y equals u to the power of 10. Okay? And then we differentiate separately, but we're careful with our notation. So that's going to be du by dx, because that's u and that's a function of x, so that would be minus 3. Y, which is a function of u, so that would be dy by du. Just the polynomial times by the power. Take 1 off the power. And I've got du by dx and I've got dy by du, so dy by dx would equal dy by du times by du by dx. So we've got dy by du, which would be this 10 u to the power 9, multiplied by du by dx, which would be minus 3. So if I multiply these two together, I'm going to get minus 3 times by 10, which would be minus 30. U to the power 9, but don't forget, like, u was just something that we introduced. There was no u in the question originally, so the final step would be to replace u, which is 1 minus 3x to the power 9. Okay, and that's like actually using the chain rule, that's what it would look like. But if we wanted to use this shortcut, it'll be a lot quicker, and I think, to be honest, it's better if you get used to using the shortcut. Okay, so we could just say d by dx of 1 minus 3x to the 10. If we follow this pattern, essentially n is equal to 10, isn't it? And our function inside is equal to 1 minus 3x. So we'll times by the power, which would be 10. We also have to times by the derivative of what's inside. And looking at what's inside, if I differentiate that, I'd get minus 3. So times by minus 3 as well. Then the function doesn't go anywhere, so it's 1 minus 3x. But we take 1 off the power, so instead of the power 10, we get the power 9. And look, we get the same answer either way. It's just like a lot quicker doing times by the power, times by the derivative, take 1 off the power. Example 9 wants us to differentiate sine x to the power 6, and it's a bit of a funny one, this. Like, a lot of people get caught out by this one, because it doesn't look like a bracket to a power. Like the one we had before, it was a function inside a bracket. Like, we've got a function to a power. It's a drawback of the notation that we use with trigonometry. Like, what we've got to realise, right, is that when we write sine to the power 6, what we really mean there is differentiate sine x to the power of 6. Like, that there mathematically means this. It's like sine is being raised to the power of 6. So we do have a bracket. It's a function inside the function. Okay, so let's do the shortcut for this one. Okay, so we'll times by the power, which would be 6. Looking at inside, we've got sine x, so that's our function inside. So we also have to multiply by the derivative, which is cos x. And then our function, which is sine x, was to the power of 6, but we take 1 off the power. And now it's to the power of 5. So we could write that as 6 cos x sine to the power 5. Example 10 wants us to differentiate the square root of 1 minus e to the 3x. Again, just be careful, like it is a bracket to a power, it is a function inside another function. Okay, so I'm going to start by writing this as 1 minus e to the 3x to the power of half. Okay. You may want to use the chain rule for this, like you might want to say, well, let's let u equal that thing inside. But if you're okay with following the shortcut, then we've just got to do these steps. So we'll times by the power. Inside, there's our function. Okay, so we have to multiply by the derivative of this. You might want to at least say, well, f of x is 1 minus e to the 3x. So you'll see the derivative. Differentiate 1, you get 0, it's just a constant. Differentiate this one, that'll become minus times by the 3. Okay, so our derivative that I'm multiplying by as well would be minus 3 e to the 3x. And then we take 1 off the power. Okay, so that would be 1 minus e to the 3x. Power's a half, take 1 off, so you get minus a half. Okay, we could tidy this up a little bit and write it in a couple of different ways. Like the main thing I'm looking at is that there. We could write it as minus 3 over 2 e to the 3x multiplied by 1 minus e to the 3x. It's the minus a half. Quite often you will see this, like if you notice the original question was not in index form, it was just a square root, wasn't it? It was a third. We wrote it in index form so that we could differentiate it, and now our final answer, we've still got it back in index form. You might want to take it out of index form. Okay, so if it's the power minus a half, that's like 1 over the square root of 1 minus e to the 3x. So we've got that there, which is being multiplied by this. We've got to be careful with our fractions. Like on the top, we've got minus 3 e to the 3x. And on the bottom, we've got 2, and we've got this third as well. So we could leave it like that. Okay, I'm going to leave example 11. I think you should be able to have a look at that one from the booklet. Good news is, guys, you're now ready to go, so you can try exercise 3, and you can do all those questions for exercise 3. And after exercise 3, move straight on to exercise 4, which is the past paper questions. Okay, we've got the word solutions for all of these up on Connect. I didn't do all of exercise 4 in terms of word solutions, but you've got the answers in the booklet. The word solutions are available for most of the questions. I would say, as a rule of thumb, make sure, whichever ones I've done the word solutions for, make sure you do at least that many. And then if you wanted to practice a few more, you could try them. And the answers are always at the back of the booklet anyway. Okay, and then if you're still not sure, just drop us a message on Teams or an email, and I can do the solutions to some of the extra ones. Okay, once you've worked through exercise 3 and exercise 4, you're then ready for the assignment, which is also up on Connect. Okay, and that needs to be submitted through Connect. Okay, thank you. Enjoy.